Now in this video we are going to focus on various treatments of sewage by answering 10 questions and its concepts. Now let's step into it. So the first question goes here. The activated sludge is what is the activated sludge? Whether it is aerated sludge in the aeration unit, or sludge settled in the humus tank, or sludge in the secondary tank after aeration and rich in microbial mass, or it is the sludge in the secondary tank after aeration and it is rich in nutrients. So what actually is the activated sludge? So in the ASP treatment we have activated sludge. So what actually is the activated sludge? So activated sludge is nothing but the sludge in the secondary tank. So the deposit that is settled in the secondary tank after the aeration process is completed, that will be called as the activated sludge, and that sludge is rich in microbial mass. Now let's see more about it. This activated sludge contains large concentration of highly active aerobic microorganisms. So note the point here, aerobic microorganism. So that means activated sludge process is aerobic culture. So that's why it is having aerobic microorganism. Contains large concentration of highly active aerobic microorganisms. So there are various treatment processes we have in ASP. So one is thickening of sludge, another one is stabilization and conditioning, dewatering of sludge, and the reduction of sludge. So what is thickening of sludge? Thickening of sludge is nothing but separating solids as much as possible by centrifuges or gravity flotation or clarifier. So you can see here sludge thickeners, gravity flotation, gravity sludge thickener, flotation sludge thickener, or centrifugal. So by using any one of these, we can thicken the sludge by separating the solids as much as possible. And what is stabilization? Stabilization is nothing but digestion, that is converting the organic solids to more inert forms. So we are converting organic solids into inert forms, inert solids, or we can say solid matter, inert solid matters, so that they can be handled or disposed of, or it can be used as a soil conditioner. So by stabilizing the aerobic organic solids, so we can convert it into a solid that will cause no nuisance or health hazard. So this is what stabilization is. So now what is conditioning? Conditioning is the treating the sludge with chemicals. So when we add chemicals to the sludge and heat so that the water can be readily separated, then that will be called as conditioning. So conditioning is nothing but treating the sludge with some external chemicals. So now what is dewatering? Dewatering is nothing but, by the name itself we can say, separating water by subjecting the sludge to vacuum or pressure or drying beds. So by using pressure or drying beds, we can separate the water from the sludge so that moisture content greatly reduces. And what is reduction? Reduction is the converting the soils to a stable form. So we are converting the soils into a stable form by incineration or by heating, etc. So these are the 5 basic treatment process for activated sludge. And what are the methods of aeration? One is air diffusion, another one is mechanical aeration, or it can be both combined. And there is another term called bulking of sludge and foaming sludge. So what is meant by bulking sludge? That means a sludge which exhibits very poor settling characteristics. So when a sludge exhibits very poor settling, it does not settle, then we call that sludge as bulking of sludge. So how it is happening? Because of filamentous microorganisms. So filamentous microorganisms such as fungi, they are found to be responsible for bulk sludge and large surface area to volume ratios. So A to V ratios of these microorganisms retard their settling velocities. So this is how bulking of sludge happens due to poor settling of sludge. And what is meant by foaming sludge? This foaming sludge is caused by the bacteria called Nocardia amare, or simply we call it as N amare. So these like organisms are growth is supported by high sludge ages and low F by M ratios, food to microorganisms ratios, and higher waste temperatures. When this condition prevail, then sludge will become foaming. So foaming sludge, that foam removal is also a logical and beneficial control measure, since these Nocardia filaments are usually concentrated in foam compared to mixed liquor. So when foam sludge is formed, then it will be beneficial for control measures. And what is rising sludge? Rising sludge is due to nitrification. So this is an this is also a problem that is encountered in secondary clarifiers of ASP, that is activated sludge plant. So this rising sludge is caused by denitrification in the secondary clarifier. So this denitrification results in the formation of nitrogen gas bubbles. So what is denitrification? Separating out. So that's why nitrogen gas bubbles will be formed, which lifts up the settled sludge. So it will cause the settled sludge to rise up, thereby deteriorating the quality of the clarified effluent. So these are the some problems in ASP plant, that is rising sludge, bulking sludge, foaming sludge. These are the some problems due to some bacteria and denitrification process. And there are some other processes which are modified in the ASP. That is, one is tapered aeration, another one is stepped aeration, another one is contact stabilization, complete mixed aeration, extended aeration, activated aeration. Step aeration is used in larger plants. Contact stabilization, that is we can also call it as bioabsorption process, that are used in medium plants. And complete mix process is used in very smaller plants, in smaller in size. And the modified aeration processes are also used in large plants. And other things are extended aeration and activated aeration processes. So these are some of the modified processes. So in the activated sludge plant, we have many concepts. So we have seen by snippets, like treatment processes, 5 treatment processes: thickening, stabilization, conditioning, dewatering, reduction. Methods of aeration: air, mechanical. Sludge thickeners are 3 types: bulking, foaming, and also the these are some problems: bulking, foaming, and rising sludge. And what are the modified process? So these many concepts are included in activated sludge treatment. Now let's move on to second. So So now let's see the second question. Biological films over the filtering media particles in trickling filter will have. So in trickling filter we have phenomenons like biological films happening, slime layer over the filtering media. So biological films in the over the filtering media particles in trickling filter will have what layer? Aerobic or anaerobic, or both the anaerobic and aerobic, or facultative layer. So what will be the nature of layers formed over the filtering media by the biological films? So these will be, the biological films have both aerobic and anaerobic layers. You can see in this diagram also. So here bed media is there. Over the bed media there is a layer called anaerobic, and after anaerobic part aerobic layer will thrive out. So these two layers are collectively called as microbial slime layer, and after that wastewater will be there, and by the wastewater only the organics will be transformed to the consumed by microorganism. That's why aerobic environment and anaerobic layers are stuck into bed media. So in trickling filter attached growth system, so that's why it is called as attached growth. So now let's see the second question. Biological films over the filtering media particles in trickling filter will have. So in trickling filter we have phenomenons like biological films happening, slime layer over the filtering media. So biological films in the over the filtering media particles in trickling filter will have what layer? Aerobic or anaerobic, or both the anaerobic and aerobic, or facultative layer. So what will be the nature of layers formed over the filtering media by the biological films? So these will be, the biological films have both aerobic and anaerobic layers. You can see in this diagram also. So here bed media is there. Over the bed media there is a layer called anaerobic, and after anaerobic part aerobic layer will thrive out. So these two layers are collectively called as microbial slime layer, and after that wastewater will be there, and by the wastewater only the organics will be transformed to the consumed by microorganism. That's why aerobic environment and anaerobic layers are stuck into bed media. So in trickling filter attached growth system, so that's why it is called as attached growth system, because the slime layer is attached to bed media. Trickling filter can be of conventional, that is low rate trickling filter, or it can be of high rate trickling filter, that is nowadays high rate trickling filter also used. In conventional trickling filter, screening and primary sedimentation is necessary, and the beds are percolating, and this is produced by population of microorganisms. By population of microorganisms, all the bed media will have slime layer formation, and after some moments or after some time there will be
So now let's see the third question. Here they have given some 8 data regarding an ASP treatment plant. Average operating data of ASP is given as first one is Q, that is wastewater flow 35,000 meter cube per day, and B is volume of the plant as 10,000 or the capacity as 10,900 meter cube, and Y naught is influent BOD concentration 250 milligram per liter, YE is effluent BOD 20 milligram per liter, and XT, that is MLS concentration as 2500 milligram per liter, and XC, that is exit. On the exit or outflow, concentration of MLS is as 30 milligram per liter, and XR, that is returned value 9700 or the recycled value 9700 milligram per liter, and QW, waste sludge, that is 200 millimeter cube per day. By using these data, we have to find aeration period, F by M ratio, sludge age, and percentage efficiency. So by calculating all the things and check with all the options, then we will get which are all the options are correct. So here option A, B, C are correct, but option D, percentage efficiency, is wrong. Let's see how these are calculated. First, aeration period. Aeration period is calculated by using for this formula T is equal to V by Q. So V here given us 10,900 meter cube divided by Q, 35,000 meter cube per day. So answer will be in days. We have to convert that in hours to get the answer as 7.8 hours. So option A is correct. And then we have to find the F by M ratio. So numerator value F, that is mass of BOD removed, that is nothing but Q into Y naught. What is Q here? 35,000 into Y naught, 250 milligram per liter. By converting into proper units, we will get the answer as 8,700 kilogram per day. And what is M value? Mass of MLS is V into XT. So 27,250 kilogram. So just divide these values to get the F by M ratio as 0.32 kilogram of BOD per day per kg of MLSs. So option B is also correct. Now option C, sludge age. How to calculate that? Theta C is equal to XTV divided by QWXR plus Q minus QWXE. So we know the values of all the things, QXT, V, QW, XR, all the things. This term is an extra term, but it is negligible term in many cases. But in this case, they have given the value for XE. So we have to use this term also, xq minus qw into xc. So by substituting all the things, we will get the answer in days as 8.58. So option C is also correct. Now option D is percentage efficiency. So percentage efficiency of BOD removal is y naught minus ye minus y naught, influent BOD minus effluent BOD, y naught minus ye divided by influent BOD. That will give answer as 92%, but in the option they have given us 75%. So that's why option D is wrong. So correct value is 92% efficiency. And there is another thing called specific substrate utilization rate, that will be termed by capital U value. U is equal to Q into y naught minus ye divided by Vxt. On substituting all the values, we will get the answer as 2.95. This is an extra point we have to remember. Specific substrate utilization rate Q into y naught minus ye divided by V into xt. There is a relation between sludge age and specific substrate utilization rate. 1 by theta c is equal to alpha y u minus ke. Ke is rate constant, that is nothing but that is usually 0.06 per day. Ke value is 0.06 per day, and alpha y is generally 1 for total suspended solids but 0.6 for volatile suspended solids. So alpha y and K are constants. One for alpha y is equal to 1 for TSS, and alpha y is equal to 0.6 for volatile suspended solids. So these are some important formulas and concepts and terms regarding ASP, activated sludge plant. Now let's move on to fourth question. Fourth question is regarding low rate trickling filter. So they have given some data regarding trickling filter. HLR is 1900 meter cube per day. Why not? HLR is hydraulic loading rate. Why not is influent BOD 150 milligram per liter. K is rate constant. N is power factor 0.6. So we have to find the value of 5-day BOD by using the dimensions also. Diameter of trickling filter is 30 meter, depth is 1.5 meter. So what will be the 5-day BOD of this scenario? Here we have to add up only one formula and substitute all the things over that formula to get the answer. Let's see what is that formula, how it is calculated. So option A is correct, 31 milligram per liter. Here we are using Eckenfelder equation. So Yt by Y0 is equal to E power minus Kd by QL power n. So we have to calculate this value only, Yt. We know Y0. What is Y0 here? 150 milligram per liter. So E power minus K. K is rate constant, that is given as 1.89 per day. So what is D here? D is depth of the trickling filter. So D is 1.5 meter. So we know the D value. What is QL value? QL is nothing but hydraulic loading rate per unit area. So that's why we are calculating Q by A. What is Q here? 1900 meter cube per day divided by A. What is area of trickling filter? Pi d square by 4. So we know the diameter of trickling filter, 30 meter. So on substituting all the values, and N is also known, 0.6. So substituting all the values, we will get the answer for Yt as 31 milligram per liter. So now let's see other important things regarding trickling filter. So the efficiency of trickling filter shall be found by using this formula. Eta is equal to 100 by 1 plus 0.0044 root u. Here u is nothing but organic loading rate in terms of kilogram per hectare meter per day. That is very important. So this unit is very important when we are substituting over here. So in this efficiency equation, u is substituted in kilogram per hectare meter per day. That is organic loading rate. And there is another thing called recirculation factor that will be given by using this formula, 1 plus r by I divided by 1 plus 0.1 r by I power 2 r square. What is r by I? R by I is recirculation ratio. R is recirculated one, I is influent one. So that's why 1 plus r by I divided by 1 plus 0.1 r by I squared. That will give the answer for recirculation factor. And if we use a two-stage trickling filter or high rate trickling filter, we have two efficiencies. By using two efficiencies, we will calculate the overall efficiency value as eta naught is equal to eta plus 1 minus eta into eta dash. So what is eta dash? Eta dash is efficiency after second stage. So eta dash is equal to 100 by 1 plus 0.004 divided by 1 minus eta root of u dash. So by knowing eta value and eta dash value, we will get the answer for eta naught, that is overall efficiency. So these are some important points regarding trickling filter and calculations. Now let's move to fifth question. Fifth question is based on, again, ASP only. Here we have to calculate sludge volume index. So a sample of sludge has suspended solids concentration of 4000 milligram per liter. So after setting for 30 minutes in a 1 liter cylinder, the sludge occupies 400 milliliter. So what will be the sludge volume index? Whether it is 100 or 10,000 or 1000 or a lakh. So here units has to be substituted in a proper way so that we will get the answer in a numerical value. Milliliter per gram actually. So SVI is given by V observed divided by X observed. So in milliliters per liter divided by milligram. So here we have to substitute like this: 1000 into 400 divided by 4000, which will fetch the answer as 100. So what actually is the sludge volume index? When 1 liter of sample of mixed liquor is allowed to settle for 30 minutes, and the settled sludge volume will be termed as we observed in milliliter, that will be recorded as to represent sludge volume. And by using that sludge volume index, we can also calculate the return sludge ratio, that is QR divided by Q is equal to XT by 10 power 6 divided by SVI minus XT. Or we can use this formula also, XT by XR minus XT. So these are again some formulas regarding ASP, regarding sludge volume index and return sludge ratio. Now let's move on to sixth question. So this sixth question is based on septic tank. Digested sludge from a septic tank is removed after a maximum period of option A 3 years, option B 3.5 years, option C 4 years, option D 5 years. So what will be the maximum period below which the digested sludge from a septic tank has to be removed? So maximum period shall be 3 years. Now let's see more about septic tank. What is basically a septic tank? It is basically a sedimentation tank having horizontal continuous flow. Septic tank removes 60 to 70% of dissolved matter and it has detention period of 24 hours or the range of 12 to 36 hours. This is the basic difference between ordinary sedimentation tank and a septic tank. In ordinary sedimentation tank, detention time shall be 4 hours to 8 hours only. But in case of septic tank, detention time is around 12 to 36 hours or basically 24 hours. And the rate of accumulation of sludge shall be basically 30 liters per person per year. This is the ordinary value. And the minimum capacity of a septic tank for 8 to 10 persons shall be 2250 to 1400 liters. So these are some basic values adopted while designing septic tank. And the freeboard value shall be freeboard given to accommodate the scum storage and also the gases of decomposition due to anaerobic decomposition happening over here happening inside the septic tank. So freeboard shall be 0.3 to 0.5 meter and width of a septic tank shall be greater than 90 centimeter and depth shall be 1.2 to 1.8 meter. So these are some criteria while designing septic tank, and L by B ratio shall be 2 to 3. And there is something called IMF tank. IMF tank is also a septic tank but having two-story digestion tanks. So this is the main difference between a septic tank and IMF tank. So these are the some main points or important things regarding septic tank. Now let's move on to seventh question. A combination of sludge, scum, and liquid pumped from a septic tank or cesspool is known as. So, what is the term that we call when a combination of sludge, scum, and liquid pumped from septic tank? Sullage, tertiary sludge, or septage. So, what is the term? So, we call that combination as septage. What is sullage? Sullage is nothing but kitchen and bathroom waste together. So kitchen and bathroom waste together we call it as grey water and that is nothing but sullage. And there is something called raw sludge, secondary sludge and tertiary sludge. What is raw sludge? The sludge which is deposited in primary sedimentation tank. It is highly odorous because it contains high putrescible organic matter. Putrescible means decomposable. And there is another thing called secondary sludge, the sludge which is deposited in secondary clarifier. So that's why it is very less objectionable because it is a treated one. And there is something called tertiary sludge when the sludge deposited after flocculation. So these are some terms regarding septage, sullage and sludge. Now let's move on to eighth question. This question is based on sludge digestion tank. Depth of sludge digestion tank is usually kept at about 4 meter, 5 meter, 8 meter, 6 meter. So what is the basic depth of sludge digestion tank? So basic depth is 6 meter. Now let's see more about sludge digestion tank. Basically capacity shall be in the range of 21 to 61 liters per capita per day and diameter of sludge digestion tank shall be of 3 to 12 meters and slope of bottom hopper shall be 1 is to 1 that is 45-degree or 1 is to 3. And there are three fractions in a sludge digestion tank. One is supernatant liquid, another one is gases of decomposition and another one is digested sludge. The digested sludge shall be very stable and it is like humus like solid matter and it is of tarry black in color and it contains very reduced moisture content. That's why the volume of digested sludge is one third of the undigested sludge volume. So removal of digested sludge shall be very easy because of less or reduced moisture content. It is also free from pathogens, pathogenic organisms, but it contains cysts, protozoa, worms, and eggs that cause reproduction. So this is a basic points regarding digested sludge. And in case of supernatant liquor, it contains high BOD value, that is 3000 milligram per liter. Its treatment is highly necessary because BOD value is very high and it is dangerous when when we dispose it into a river or natural lakes or rivers, natural water bodies, and it contains finely divided solid matter. And there is another thing called gases of decomposition. So mainly methane will be there, and another thing CO2 will be there. So by using methane as a fuel, you can use methane as a fuel. So that's why gases of decomposition is useful. So these three fractions are regarding sludge digestion time: digested sludge, supernatant liquor, and gases of decomposition. Now let's move on to ninth question. In aerobic environment, nitrosomonas convert ammonia to nitrogen dioxide, NO2 to NO3 minus, NO, NH3 to NO2, and option D, NO2 to HNO3. So what is the basic correct option that nitrosomonas convert? So option A is correct, ammonia to NO2. Now let's see the what is nitrification and what is denitrification. We have already seen a denitrification term in the one of the previous questions. Due to denitrification only, rising sludge happens. That will cause scum layer. And nitrification happens by nitrosomonas bacteria. Nitrification is happened by nitrosomonas bacteria that will convert NH3 to NO2. That is oxidation. And nitrobacter will convert NO2 minus to NO3 minus. Again, further oxidation. And denitrification means reduction NO3 to nitrogen. That will be caused by Paracoccus denitrificant. So these are the some points regarding nitrifications. Now let's move on to the last question. Sewage treatment in an oxidation pond is accomplished primarily by. So what is that phenomenon? Algal photosynthesis, bacterial oxidation, algal bacterial symbiosis, chemical oxidation. So what is that phenomenon? Basically achieved while sewage treatment in an oxidation pond. So that phenomenon is called as algal bacterial symbiosis. Now let's see how it is happening. First, the algae grows in presence of sunlight, and that algae produces oxygen by photosynthesis action. So that oxygen is utilized by bacteria for oxidizing the waste organic matter. So by oxidizing that waste organic matter, end products are got as CO2, ammonia, phosphate, and H2O. These end products again utilized by algae, and again it will produce O2. Again that will be consumed by bacteria, that will decompose the waste organic matter. Again that will produce CO2 and NH3. This cycle happens. This is called as algal bacterial symbiosis. So we have learned more things about treatment of sewage. If you like this video, please like, comment and share with your friends also. Thank you.